What is differentiation? Differentiation is a process of finding a function that outputs the rate of change of one variable with respect to another variable. So, basically, differentiation is a process of finding the derivative or rate of change of a function.
Derivatives are a fundamental tools of calculus. The derivative of a function of a single variable at a chosen input value when it exists is the slope of the tangent line to the graph of the function at that point. The tangent line is the best linear approximation of the function near that input value.
Ta-da! It is the definition of derivative.
Then, what is related rates? In related rates application, we try to find the rate at which one quantity is changing by relating it to other quantities with known rates of change. The rate of change is usually expressed with respect to time.
Next, the objectives are to find the rate at which one quantity is changing. Secondly, to be able to change quantities in terms of derivative. Thirdly, to be able to solve various rates of change of application. Then, to find relationships among the derivative in given problems. And lastly, to use the chain rule to find the rate of change of one quantity. So, the next thing that we are going to discuss is the strategies for solving related rates. First step is to assign letters to all quantities that vary with time, which means over dt. Second step is to identify the rates of change that are known and the rate of change that is to be found. Third step is to find an equation such as area, volume, Pythagoras theorem, and trigonometry ratio that relates with the variables. Then differentiate both sides with respect to time. And lastly, after differentiate both sides, substitute all the known values and solve the problem. Next, we are going to see the problem statement which related to the related rates topic. The question is, a 30-meter ladder is leaning against a wall and sliding towards the floor. The top of the ladder is sliding down the wall at a rate of 7 meters per second. Thus, how fast is the base of the ladder sliding away from the wall when the base of the ladder is 12 meters from the wall? Okay, so there are few things that are already given by the problems and few things that the question wants us to find, such as. So firstly, the question wants us to find the rate of change of the base of the ladder sliding away, which means dx dt. Given the base of the ladder, which means x, is 12 meters from the wall. So in the question, they already gave us the rate of change of the height of the wall, dh over dt, which is 7 meters per second. Then we need to find the original height of the wall, h, by using Pythagoras theorem. And lastly, the equation for the question, which is related to the Pythagoras theorem equation.
Thank you, Sarah. Now let's move on to the problem solving. So as we all know, the dh over dt is equals to negative 7 meters per second, and we need to find the dx over dt, which is the rate of when the base of the ladder fall from slide away from the wall. So, which is dx over dt when x is 12. So here it is 12. Okay, so first of all, we need to find h. So to find h, we can use Pythagoras theorem. So 30 square minus 12 square instead of 13 square minus 12 square equals to 25. So H is 5. So right now we know the value of H, which is 5. So we are going to use this formula and to find the dx over dt. So in order to find dx over dt, we must differentiate x with respect to t as well as h with respect to t. And yeah, so we're going to apply implicit differentiation. So x becomes 2x, and don't forget to attach it with dx over dt plus 2h, attach it with dx over dt, dh over dt, and 13 square becomes 0. So since we need to find dx over dt, so we need to make dx over dt as the subject matter. So dx over dt with negative 2h, dh over dt divided 2x. So now, once we get this, we have to substitute the value for each term. So and I have listed the value here. So dx over dt equals to negative 2. So h is 5. So 5. And dh over dt is negative 7. So this is negative 7 over 2x. So x is 12. So from here, we can just use calculator and calculate it. So dx over dt, we'll get 2.917 meter per second for the dx over dt. Make sure not to forget the units. And that's all. Thank you.